tips.
I am Rob Sassana.
So my name is Kira Fleming.
Burton has these new progression bindings, step-on bindings that they're prototyping right now. And they need to test the wear of the toe hooks and of the general binding as a whole so that they can adapt the binding as they go down the road before they release it in years to come. And they need a way to test for that wear.
Burton wants us to build this testing device because they need it. Without this device, they would basically just have their theoretical calculations and not know what is really happening over a full lifetime. They can put it out in snow, they can talk to, they can have riders ride it for as long as possible, but there's no real way to get a full life cycle.
We played around with the idea of moving just the binding instead of moving the boot, and then also moving both at the same time to try to create the right motion.
Because it's a tipping motion, we need to make the base a little bit wider to provide that size, but on the contrary, the tipping motion allows us to have the binding stationary and the device moving, which is more realistic to what's actually happening. And in the consumer's eyes, you can kind of understand what's going on a little better than if the binding is moving.
It's kind of a combination of a tipping motion so that the boot can get the correct angle to release from the binding, as well as the up and down motion required to get the boot in and out. So as the device tips, there's also crank arms spinning on the tipping towers that cause the boot to go up and down. So we have one crank arm on the left that causes the tipping, and as it's tipping, the crank arm on the right is causing the up and down cycle motion. And we have those timed perfectly so that the boot will be at bottom dead center in the binding at the back of the tipping cycle and completely out of the binding at the front of the tipping cycle.
Oh man, we've had a lot of opportunities on what we can use. So probably our biggest help with this project has been our SLS prototyping. Just here in Burton, being able to use that every single week, pumping out new designs that we build. Besides that, right now we have bevel washers being printed in the Object Connect printer. We've used the TAS 5 to prototype bushings. And then just past that, just Burton's facility with the mills and filers and really everything else that's it to our accessibility.
We're basically going to test our device just how we would with the bindings, just like doing a cycle test again and again, making sure that it lasts, and if any parts fail, we'll replace those pieces.
So we did general stress analysis of both shafts and some of the critical components. And then we also did other analyses to determine with our motor if we'd be able to get the 1,000 cycles per hour that's required of our device.
We did succeed in solving the problem. We created a more ergonomic in and out testing device. It's smaller, lighter, easier to use, and more robust. That being said, I do think that the device could be improved on. It could be a little smaller, could be lighter, as always. And in the future, I can see this device becoming more accurate, replicating that human-like motion to a higher degree, as well as simply providing more accurate results through the use of additional sensors.
Is it gonna work?
It's gonna fucking work.
It's gonna work. He says it's gonna work. You guys say it's gonna work.
It's gonna work. It's gonna work.
The finger crusher.